Alright, let's look at some of the problems in 13.5. Number 2, I want the line through 1, 0, negative 3 parallel to 2, negative 4, 5. Well, then they're going to have the same direction vector if it's parallel, and this is the point, so it's just going to be x equal x1 plus at, y is 0 minus 4t, and z is negative 3 plus 5t. So remember, this is the point, and this is the direction vector. And that's all you do. So I want the equation line through the origin, parallel to the line x equal 2t, y equal 1 minus t, z equal 4 plus 3t. So again, it's the same direction vector. Just use dv for direction vector of this line, which is 2, negative 1, 3. So I have x equals 0, the point, plus 2t from the direction vector, 0 minus 1t, and 0 plus 3t. So my line is 2t minus t, 3t. I could write it as that vector. It's all the points represented by that vector, all the endpoints. Okay, number 8. I want a line through 2 points. Okay, I want to find the vector representation because that's going to be the direction vector. So that's going to be 2 minus 6, 4 minus 1, 5 minus a negative 3. That's going to give us our direction vector. We'll use this point right here. So we have a point in the direction vector. So our line is x equal 6 minus 4t, y equal 1 plus 3t, and z equal minus 3 plus 8t. And the symmetric equation is going to be x minus 6 divided by negative 4 equals y minus 1 over 3 equals z plus 3 over 8. So these are the symmetric equations, and these are the parametric equations that give us equations of that line. Okay, in 10, I want the equation of the line through 2, 1, 0 orthogonal to I plus j and j plus k. So the normal vector here, no, these are, I want the direction vector. The direction vector for this one, or the vector representation, is 1, 1, 0, and for this one, it's 0, 1, 1. So let's let this be A, and this is B, and these are the direction vectors, or the vector representation. And we want it orthogonal to that, so we take the cross product. That's going to get us a vector orthogonal to both A and B. And that's going to be I minus j plus k, which is the vector 1 minus 1, 1. So that's going to be the direction vector for our line. So we're going to use this point, and this is the direction vector. So x is 2 plus 1t, y is 1 minus 1t, and z is 0 plus 1t. Those are the parametric equations. And it's just as easy to get the symmetric equations if you need them. Let's look at number 12. I want the line of intersection of the two planes x plus y plus z equal 1 and x plus z equals 0. So the normal vector for this plane is 1, 1, 1, and the normal vector for this plane is 1, 0, 1. Those are the coefficients of x, y, and z. And if I want to do get the line orthogonal to that, that'll lie in the plane. So n1 cross n2. And that's going to be the direction vector. Remember, the plane is all points orthogonal to the normal vector. So if we have the normal vectors of these two planes, and if all the points orthogonal to those are going to be in the plane. So this is going to be our direction vector. If we let z equal 0, we get the point, we get the intersection in the xy plane. So we get x plus y equal 1 and x equals 0, but then that means y equal 1. So we have the point 0, 1, 0. So we have x equals 0 plus 1t, y equal 1 plus 0t, and z equal 0 minus 1t. So x equal t, y equal 1, z equal negative t. Those are the parametric equations for the line of intersection. Okay, let's look at number 20. I want to know if these are intersecting, parallel, or skew. So I have two lines. Okay, I set these two equal and these two equal. And see if it satisfies this last one right here. So I set these two equal and these two equal. Now I'm going to multiply this equation by a negative so the s's drop out. So I have minus 1, then I'm going to add them, plus t equals 5. And that's going to make the s drop out. So t is going to be 6. And if t is 6, I plug it back in here. I get 18 equals 4 plus s. S is 14. So let's take these two, plug them in here. So I have z, those two should be equal. 2 minus t, which is 6, is that equal to 1 plus 3 times s? Those are not equal, so they're not intersecting. There's no scalar that satisfies all three. Let's look at their direction vectors. If they're scalar multiples, then they're parallel, but there's no way those are parallel, because if you multiply, if k is 2 to get x, k would have to be 2, but it won't work for the rest of them. So they're not parallel, so that implies they're skew. Okay, 24. I want the equation of the plane through the point 4, 0, negative 3 with the normal vector equal to 0, 1, 2. All I have to do is say 0, x minus 4 plus 1 times y minus 0. I take the point, subtract them, plus 2, z plus 3 equals 0. So I have y plus 2z equals minus 6. Here's the equation of the plane. Minus 1, 6, minus 5 is a point in the plane. And I want it parallel to this plane. So if the planes are parallel, then their normal vectors are parallel, so they have the same direction. So they have the same direction vector, which is 1, 1, 1. Well, actually, they're the same normal, I guess it's the same normal vector, which is in the same direction. So there I have the normal vectors. Then all I have to do, and I already know the point, so all I have to do is say 1 times x plus 1 equals 1, or plus y minus 6 plus 1 times z plus 5 equals 0. So x plus y plus c equals 0, because the constants drop out. Okay, let's look at 30. The plane contains the line contains this line, and it's parallel to 2x plus 4y plus 8z equals 17. So again, if the plane's parallel, it has the same normal vector, which is 2, 4, 8. So I have the normal vector. Now all I need is a point. Let's check this though. The direction vector of this line so if I dot them, these should be orthogonal. Okay, so the direction vector of the line and the normal vector in the plane are orthogonal, so I just want to check that. Let t equal 0, and that's going to give me a point on the plane. You could let t be anything and get any point on the plane. So then you get x equal 3, y equals 0, z equal 8. So the point is 3, 0, 8. So my equation is going to be 2 times x minus 3 plus 4 times y minus 0 plus 8 times z minus 8 equals 0. And you can work that out more and distribute it to see what the final answer is. Okay, number 40. If x equals 1 plus 2t, y equals 4t, z equals 2 minus 3t. That's the line. And the plane is x plus 2y minus z plus 1 equals 0. We're trying to find the point of intersection, so we're just going to substitute those in. So we have 1 plus 2t plus 2 times 4t minus 2 minus 3t plus 1 equals 0. This gives us 13t equals 0, which tells us t equals 0. So if t equals 0, we go back here and get our point, then x is 1, y is 0, z is 2. So the point of intersection is 1, 0, 2. The line's going through the plane at that point. .42. If I have 2 points, then the direction vector of those is 3 minus 2, 1. And let's see, we're asked to, where does it intersect the plane? X plus y plus z equals 6. Where does the line that goes through those 2 points and this thing intersect? So I have the direction vector and I have a point. So this line is x equal 1 plus 3t. I'm going to use this first point. 0 minus 2t, and z equals 1 plus 1t. If I plug those back in here to see where they intersect, that's x, this is y, this is z. I get t equal 2, and then I plug that back in here, and I get the point. So the point of intersection is 7, negative 4, 3. So I had to find the equations of the lines first, and I already know the equation of the plane, and I just substitute them in to get the point of intersection. Okay, let's try a few more. 46. I want to know if they're parallel, perpendicular, or neither. So the normal vector for this one is 1, negative 4, 2. And this one looks like a multiple of it, and yes, it is. N2 is 3 times N1. So if the normal vectors are, so N1 is parallel to N2, that means planes are parallel. Okay, the normal vector for plane 1 is this, and for plane 2, it's this. If you look at the problem, well, N1 is not a scalar multiple of N2. You'd have to multiply N2 by 2 and that to get at least the x's to be right. So they're not parallel. If they're perpendicular, then their dot product should be 0. So let's dot these two. And that is 0. So the planes are orthogonal since their normal vectors are orthogonal. Okay, the normal vector for plane 1 is 1, negative 2, 1. And the normal vector for plane 2 is 2, 1, 1. So let's get the vector that's orthogonal to that, and that will be the direction vector in the plane. That's n1 cross n2, so that'll be the direction vector for any vectors in the plane. Okay, so I let z equals 0 to get the point. Have a to get the line, I need a direction vector and a point. So if z equals 0, I have x minus 2y equal 1 and 2x plus y equal 1. I multiply this equation by minus 2, and I get 5y equal negative 1, y equals negative 1/5. Plug it back in here, and I get 2x equal 6/5. And if I divide it by 2, I get x equal 3/5. So the symmetric equations look like, and again, these are not unique, so if you find a different point, you're going to get a different answer. And that would be for 52. Now to find the angle between them, I do cosine theta equals, you dot the normal vectors and take their magnitudes. Their magnitudes are both 6. And if you dot them, you get 1. So when you do that on your calculator, you get about 80 degrees. So the angle between those two planes is 80 degrees. All right, I hope this helps you with some of the problems you try.